Hi, I'm an old guy and I do maths. The job today is to try and graph this exponential function. Y equals y equals 2 to the negative 2x plus 1 minus 2. Those of you who are familiar with exponential functions, you may well realize that this is some indication of an asymptote. And we'll look at that as we move further along. Now, the other thing is that those of you who have seen me, or seen my video rather, of my graphing an unknown function, will know that I have a basic method. So if I can't immediately recognize how something's going to look, I go through this process, and I'm going to go through it today. Because it's a pretty foolproof way of working your way through something like this. But having said that, we will be able to extract some general rules about what happens to an exponential graph when you do this and this to it. Okay, so let's get going. First thing is to try x equals 0 rather, in this function. And when we do that, we get something that is both helpful and unhelpful. We discover that this thing passes through the origin, because if we make x equals 0, that's 2 to the power of negative 2 times 0 plus 1, which is 2 to the power of 1 minus 2. 2 to the power of 1 is 2, minus 2 is 0. So this thing passes through the origin. But where does it go either side of that? That is the question. Because it passes through the origin, it won't pass through. It's a fair bet anyway, because it's an exponential function, that it won't pass through anywhere else on an axis. So we're looking at finding points in the rest of the Cartesian plane to try and get a handle on how this looks. So the first thing I'm going to do is I'm just going to put 1 into this equation, and what I get from that is 2 to the power of negative 2 plus 1, which is 2 to the power of negative 1 minus 2, which gives me a half, 2 to the power of negative 1, 1 over 2, minus 2, which gives me negative 3 over 2. So I've got a point I can plot on the right-hand side of the y-axis. X equals 1, y equals negative 3 over 2. Which tells me that this is in the bottom right-hand quadrant, the fourth quadrant. And that gives me some clue as to how this thing is going to look. Right, so where to from there? Well, given that this goes through 0, 0, the obvious choice then is negative 1. And what happens when we do that? Well, negative 2 times negative 1 gives me positive 2. So this is 2 to the power of 2 plus 1, 2 to the power of 3, which is 8, minus 2, which gives me 6. So I have a point to plot, negative 1, 6. And when I plot these points, this is what I get. Now remember, I've got 3 points because I know that. I know that this is an exponential curve. And exponential curves, the standard one looks like that. So it's got this sort of hockey stick formation. I could keep going. I could put negative 2 and positive 2 into this, but I'm pretty certain that this is what we're looking at. We've got an asymptote of negative 2, which we can get immediately from this. But we can come close to a proof of that simply by inserting some more values, and what you will see is that the y values will approach but never touch negative 2. So what lessons can we draw from the way that this function is constructed and how it's graphed? Well, there's the obvious one about the asymptote. More interesting is this. What this does is it moves. I'll just show you. It's easier if I draw it. Here is my standard exponential function. If I merely make the index part of this function negative, what happens is this. that's the rule to extract from this. Okay, I hope this was helpful. I hope it was interesting. There will be some more of these